What's up, guys? 2014 Ford Explorer, the 3.5 Ecoboost complaint passenger seat. Won't go up or down. I guess you would call it the I don't know. Hold on one second. So this switch right here is supposed to raise and lower the seat. They call this the rear motor height, motor. That's that guy right there. You can see my front probes are, you know, my probes are on there, and that's because I was using the power probe to try to power the motor, and it won't go anywhere. But let me get these off of there quick. So here's the connector. We've got a yellow gray and a blue white, or a white blue rather. Now the way this motor works, or these motors work, is, you know, them two wires go back to the switch assembly. Okay, this one right here, right? So when you pull up, it closes the circuit, and when you push down, it closes the circuit, or the switch rather. Now those two pins right there are full-time ground right now, and you know, when you push down or up, depending on which way you want the motor to go, one side's going to turn into a power feed, and the other side's going to turn in, the other side just remains that ground. Okay, that's how it works. So it's pretty straightforward to test this. Now I took a you know, a 5 amp test light and tested it just to confirm, but down and dirty, I'm on B positive here, coming from the cigarette lighter with my test light. It's a pretty easy check. You can see we got a good power feed to the tip of my, well, our connection's good with our test light. So all we need to do to test this switch assembly is, let me get set up. Okay, so I'm touching on one side. I think I'm on the, doesn't really matter. Both sides should be a ground when I'm not touching the switch, and you can see I'm touching that side and it's a ground. Now let me touch the other side. Okay, so I'm on the, well, hold on. So I'm on the other side of the connector. You can see I got a good ground, okay? Now I'd get you in there, guys, but it's really hard to do that and film at the same time. Now watch as I press the switch. All right, so I'm on the upside of the switch. So if I press up on the switch, hold on. So I'm gonna press up on the switch assembly, right here, up. You can see that light go out. Now what that means is that's because it's losing the ground and it's turning into a power. So if I were to switch polarity and go to, you know, the negative side there with my test light, basically hooked to ground, that light would be lighting instead of going out. But because it's going out, okay, I'm not worried about it. But I'll show you. So now let me go to the other side of the switch, or the connector rather, and we'll check that. That would be the down. Okay, so we're on the down side, so I'm going to push down on the switch, and you can see it goes out. Okay. Now let me show you what that looks like if I go to, if I switch polarity. So I'm going to go to I'm going to hook my test light to ground right now, and when I push down, instead of the light going out, the light's going to come on. Okay. Okay, again, I'm just resting on the pin there. I'm hooked to ground. And you'll see as I push down on the switch, our light comes on, okay? It tells me my power feed is there. Let's switch it around and let's go up with it. Okay, so going up, on. So that tells me my switch integrity is there, guys. Obviously I could bust out the 5 amp test light and show you that check that I did just to make sure it could carry a load. It worked, trust me, you're gonna have to take my word for it. The other thing is when you've seen those green probes I had in there on the actual motor itself, that was so I could take the power probe, give one side of ground and the other side of power, and see if I can manually move that motor, and of course I got nothing. So we're done. It needs a motor, no doubt about it. Now with these 2014 seat assemblies, you have to replace the whole C-track assembly because they don't list that motor separately. I think the only one that you can actually service separately, if I was looking at it right with my parts guy, or our parts manager, was the horizontal, or Yeah, I guess that would be considered the horizontal, you know, the forward and the back motor for the C-Track. But nevertheless, got to do a whole C-Track, and it sucks because I think list price on it was like $900 some. So if you're a customer out there and you're buying these new cars and you got all the fancy stuff in the power seats, better have a good warranty, because once a motor goes out, the whole seat assembly, the whole seat track assembly, this whole track assembly down has to be replaced. Pretty wild. Anyways, have a good day, guys. Alright, real quick circuit design of this 10-way passenger seat switch assembly, okay? And you can see here we're on power seat circuit 10-way passenger seat. So, what I was testing in the video is we were testing this rear height motor circuit, okay? But what I want to show you is how this passenger side front seat control switch assembly is wired. You can see here we have a fuse coming from the battery junction box, a 30 amp 42 fuse 42. That's a hot at all times fuse, and that comes down and it ties into all of these trees for each of these switches, okay? We have our lumbar switch, our recline switch, our rear height switch, our horizontal switch, and our front height switch, okay? 10 different movements, if you count them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different movements, 3 actual switches, physical switches if we look at the actual seat, 3 switches, but this switch here has 3 motors involved. You've got front height motor, rear height motor, and your horizontal motor. Then of course this is our lumbar, which is the inflate for, you know, the arch in your back motor, and then you have your recline motor, okay? So don't get confused on that. 5 different motors doing 10 different things, 3 actual switches on the physical seat control switch panel, but 1 switch has actually got 3 motors assigned to it, if that makes sense. So looking at the wiring diagram, you're going to see that it's going to be drawn, that front switch that we were pressing, you know, for our rear height. There's 3 different switches in one, okay? But they're not showing that like as one on here, if that makes sense. Again, these are power side switch circuits. They are drawn in the rest position, the open position. They are all, if you look here with these little arrows and the dotted lines, those are the actual, what that dotted line is telling you is these 2 move together, these arrows, the switches, okay? So when you push it one way or the other way, they're going to move parallel to one another. They're all defaulted in the ground position, because if you look, you'll see how they come up and they're tied into this leg here, and they all come to right here and come down to ground G302 on the right rear quarter panel. So they all share the same ground, they all share the same power feed, they all work except for the rear height motor, not worried about power, not worried about ground, to the switch assembly. No sense in going there. Easiest check would be go right to the motor itself that's not working, disconnect it, and do our checks there. And that's exactly what I was doing in the video. So when I had my test light, initially I was hooked to battery positive, okay? My test light was hooked to battery positive, and because I knew after looking at this that all of these should be a ground in the rest position, when I touched, you know, pin 1, the white blue there, disconnected of course, I knew that my light should light. And if it does, that tells me, same thing on the other side, the yellow gray, and if it does, that tells me that this part of the switch, okay, internal to the switch assembly or the control assembly is good. Okay, it's able to carry a load back to the ground. Same thing on the downside, and same thing when we were actually physically switching it, okay? We were able to see, so for example, when I would push up on the switch, if we look here, if you push up on the switch, the upside, again, power side switched, is going to go to the power, to the tree there. It's going to get its power feed. The switch is going to move this way to the power, switching the white blue to a power, okay? Test light's hooked down at the connector to battery positive still, right? And I had the test light in there. So test light's lit right now because I'm not pushing the switch. Once I push the switch in the up position and this switches to a power feed, okay, because I'm hooked to battery positive with my test light, the test light's going to go out, okay? Because it's not finding its path to ground anymore, all right? If I were to hold that switch in the up position with test light still hooked to battery positive and just switch over to the downside, because the downside is still a ground, because that's basically going to move to the left here, that test light would remain lit, okay? I didn't do that in the video, but just trying to get your head wrapped around it. Now, if we switch our polarity of our test light to ground, hooking it to battery negative, right? And then I were to touch, not touching the switch, I were to touch the white blue, the up side, or doesn't matter, either side, hooked to battery ground, in the rest position, because I'm hooked to ground, and it is a full-time ground, I'm not going to have a lit test light. The only time I'm going to have a lit test light is when the switch moves to a power, okay? So if I'm in the upside on the white blue with my test light hooked to battery ground, and I hit the switch, I push the switch up, it's going to switch to a power and my test light should light, and it did, okay? That tells me that this part of the circuit going up to the fuse from the switch is good, okay? It's able to light the test light. Again, I was using a standard incandescent test light. I also tested it with a 5 amp test light just to make sure it could carry a load. Same thing in the downside. I switched my test light hooked to battery negative. I switched my test light over to the downside on the yellow gray. Again, down at the connector, disconnected from the motor, just touching it. Test light hooked to battery positive. I pushed down on the switch, or test light hooked to battery ground, rather. I push down on the switch. It's going to switch to a power. Test light's going to light. Okay? I hope that makes sense. Okay? That's what I was doing in the video. Now, I didn't show this part, but the last part, if all that checks out, that tells me wiring integrity all the way through the switch, up to the fuse, and to the ground. All those wires are good, okay? It's not a wiring issue. I'm suspicious of the motor at this point, okay? Do I need to even check the motor at this point? Not really, because I already know it's a motor problem. But just to be 100%, I take my power probe, I put some front probes in on the motor, okay, again, disconnected from the motor. There's no wiring hooked to the motor other than my front probes. Then all I'm doing is I'm taking my power probe and I'm giving one side of power and the other side, I give one side the ground and I give one side of power, and the motor should move one way and flip it around and, give power to this side, give a ground to this side, and the motor should move the other way. Of course, nothing moved. We were done. Needs a motor, okay? So, that's it in a nutshell. 7 minutes, almost 8 minutes here of yapping away, but I hope that makes sense for any of you guys wondering. Anyways, have any questions, drop them down. Thanks for watching, guys. Appreciate you, and I'll see you on the next one.